Hi guys, this is our presentation on modeling of the trajectory of an oil spill in a large domain. My partners are Sandra and Suman. My name's Nathan. Getting into my results. This is what I did last week. I just got acquainted with ANSYS by modeling a 2D side view of a tank with oil and water mixing as a flow. This week, my objectives are to create a 2D top-down view that matches the study better, to simulate the spill as a monophasic case with oil as discrete particles rather than another phase. This is the domain that I used. It's similar to the one in the study, just scaled down by a factor of 1,000 with the same boundary conditions. This is an animation of the contours of oil density that I got. So as you can see, I'll skip ahead here a bit. But the oil just comes out of this inlet and then pools up in this right side here. Uh, so it's behaving fairly well, but it's still not close to what we need from the desired result, which is what they got in the study, which is the spread coming out here to the left more. So next week, to get closer to this, I'm going to add an angular acceleration term, change the velocity at the inlet to a time varying function, and then check if I need a 3D mesh to simulate properly.
Hello, so this was my simulation for last week where I injected oil into a 2D domain. For this week, I simplified the model and modeled it to be similar to the shape of the coast. I also had it scaled down to reduce on the computational time and made the edges of the boundaries a little bit smoother so that I could have an easier time meshing the domain. So this was my results for when I simulated the oil spill. I have the oil injected here at the inlet, and here I noticed that there's a little bit of turbulence happening here at the inlet. I modeled the flow as a turbulent flow with oil as a discrete particle in a single phase with water as the main fluid. The simulation starts happening according to the fluid time step, which is 3 seconds. The boundary conditions were the same as previously with the velocity at the inlet and the outlet. And this is what I got for the velocity happening within the fluid and the domain. So for the oil spill and the oil trajectory, the results I got was the concentration of the oil particles still seem to be at the inlet, at the oil inlet, but they're starting to spread out further into the fluid. I hope that for the next week, I can simulate it to be closer to the paper's simulation. For this simulation, I had followed all the solver settings in the paper. However, I was not able to add the shear stress as a boundary condition at the top domain. That's what I hope to achieve next week, as well as simulate the oil over a longer time to carve out a path or see an oil trajectory in my results.
Hey, last week we discussed the time of society, and this week we'll be discussing about the graph of the equivalent shear stress at the sea level due to the wind. This graph showcasing the components in X and Y. You can clearly see that the both components show a clear pattern of fluctuating over the 30 hours of period, indicating the variability in shear stress due to changes in wind speed and direction. The X component maintains a narrow range, staying closer to zero, which suggests a more stable behavior. But compared to the Y component, which showcases several peaks and drops over the time period of 30 hours. And in the end, the both components shows to appear peak and drop at the same times, but the Y component shows more extreme changes, suggesting it more sensitive to the changing wind condition. And the next graph is uh, anything, yeah, and this graph indicates the velocity at the inlet of the domain over 30 hours. I can clearly see that the pattern is in the periodic way, and also the velocity crosses the zero line repeatedly, uh, indicating an altering direction of the flow. And the positive suggests the water is moving into the domain, which is at the top, and the negative is the water moving away from the domain, which is at the bottom, and both having a peak velocity slightly above the 0.4 meter per second, and the lowest is just below the negative 0.4 meter per second. And the other pattern which can be seen is the peak drop appears at the regular interval of every 6 hours. And this is the update for the week. I'll be working on effective speed and velocity comparing the X5 and total induced velocity. Well, thank you.